All right, so I skipped exercise 4 because it was more of the same, but exercise 5 is our last type of question, which I call a tricky normal. So these don't happen very much in real life, but I do like them for exam questions because they're really the only way that I can verify that you guys understand how the z-score is related to this whole process. Because with the calculator shortcuts, you can get pretty lazy and not realize how the standard normal is involved. So in a tricky normal question, you're going to be given both the cutoff and the percent, and I'm going to be asking you to find either the mean or the standard deviation. That's the piece that we will not know. So I'm going to ask you for a parameter. And since you don't have the mean and standard deviation, you won't be able to use inverse normal, normal CDF the traditional way. So we will have to use our steps. We'll have to use something. So the way we're going to do this is we're going to move backwards instead. Except for not to x. This will take us to a mu or sigma. So let's see how this would look. So the first exercise here, I've taken out all of the words and it's just given you, like, if you translated everything, here's what you have. So if we knew we were dealing with a normal question, they gave us a mean of 20. They gave us a percent. Oops, keep doing that. They gave us a percent, and then what this was above. So 25% is above, so we know we're doing it with the right side, and 22. So 22 is above 20, and we want above, and we know that this is 25%. This question, we want to know what the bunny hops were to get to 22. Okay, so first step is going to be to take that percent and turn it into a z-score. So if we want to turn this percent into a z-score, we're going to use inverse norm. And instead of this 25% because it's on the right side, we're going to use 75% for the left. Right? No need to put in a mean and a standard deviation, but if you have a calculator with the actual, sorry, I want to move all this stuff over. If you have a calculator with the wizard, I do want to take a moment here. You do need to tell it that your mean is 0 and your standard deviation is 1. I know that we have a different mean, but we want a z-score. We want to use the z-scores here. So if we do this z-score out, let me get my little wabbit. Okay, so inverse norm, 0.75. We get 0.6745. This is telling us for the underlying normal distribution, centered at 0, the standard normal, this thing is 0.6745 standard deviations above our mean. So we're less than 1 bunny hop away from our mean. So then the next piece is, well, that's great, but what exactly was our bunny hop? So we're going to use that z to get out mu or sigma. And this is all about, as soon as we use the inverse, we're going to use that inverse formula on our formula sheet. So remember this inverse formula? We're going to use that one. You could also use this formula, but I find that students tend to have trouble with the algebra on the other one and not so much with this linear version there. So we're going to write that formula down. X is equal to z times sigma plus mu. We know our x. This is that 22 we observed. That's our cutoff. We just found our z-score of 0.6745, which made sense because it was above average. We don't have the sigma, but we do have that mean of 20. So this is the hardest amount of algebra we ever do in this class. We're going to have to solve for this sigma. So we're going to get rid of that friend, get rid of the 20. So we have 2 is equal to 0.6745 times sigma. Divide both sides by that 0.6745, which gives us that our sigma is equal to 2.9652. And then if there were units, we'd actually want to make sure that we have units. Any inverse question is going to have units. So z-scores for the sigma and the mean, mu, we also have units. This is a question without any units, so we're actually fine. So I want you guys to try the next one. Once you're done, we'll come back. In this case, We do not know what the mean is, so our drawing is a little bit harder. But we have this piece. We know 20% are below 100. So we don't know if 100 is above or below, but we do know that that 20% is on the left. So we're going to shade till we shade about 20% of the curve. And, oh, that's below 100. So we don't know what our mean is, but right off the bat, we know our mean is something greater than 100. And again, we're going to have to go through those steps, percent to a z. So our z is going to be equal to inverse norm, 0.2, 0, and 1, if you have the mean and standard deviation to put in there. Which should give us out a negative z-score since we were below average, right? So negative 0.8416. And then step 2, so that's step 1, is going to be to use that same formula. X is equal to C times sigma plus mu. Our X is that cutoff of 100. Our z-score we just found, 0.8416. Standard deviation was also given. And then we have the mu that we're looking for, right? Plus mu. So we're just going to add this piece, whatever the heck that is. And you can always do the multiplication out if you want to ahead of time. But it doesn't really matter, so we could do that times 15. So we have negative 12.6243 plus mu is equal to 100. And then we just need to get rid of that negative 12 by adding it. So our mean is equal to 112.6243. Again, we throw units on there, but this question is just basic. So that's the inverse, tricky inverse. That's the two ways it can happen. We could either be finding the standard deviation or finding the mean, but the steps are exactly the same. Inverse norm and then the inverse calculation.